In this video, we look at the random process. The random process involved with random variables and time. So there are two variables there. One is random variables, another variable is time. For example, signal x of t is equals to a cosine 2 pi f naught t plus theta. And theta is actually random, is uniformly distributed from 0 to 2 pi. In this case, x of t is a random process because there's a random variable involved and also a time involved. So that's the definition of random process. A random process is much more complicated than a single random variable. If given a time, if time is given, for example, if t equals to 1 second, so x of 1 equals to a cosine 2 pi f naught multiplied by 1 plus theta. And we can see here this random process now at time equals to 1 second, it becomes a random variable. A random process becomes a random variable for any given time. That's what I exactly said here. At any given time, the value of random process is a random variable. So this notation, x, big X, random process, t naught is a random variable as t equals t naught. That's the same thing here. If I look at time equals to 1 second, x1, for this example, you can see this is a random variable related with theta. So now let's look at the mean of the random process. The mean is we take the expectation at one given time, t naught. If we know the PDF function of given time t, we can do this integral ex multiplied by this PDF function. We do integral from minus infinity to infinity. In this notation here, this is one function, a little bulky, but because of the subscript x t naught, that's one random variable, and small ex, that's the value. So this is really just one function. It's related with t naught and the function of small ex. So this is a PDF function of the random variable ex t naught. Let's see here, x of t equals to 3 cosine 2 pi t plus theta, and theta is uniform distributed from 0 to 2 pi. Let's find the expectation of x t naught, and that's the expectation of 3 cosine 2 pi t naught plus theta. If we want to calculate this expectation, this is a random variable theta, and this cosine 2 pi t naught plus theta is a function of random variable theta. And we know this, if I have this expectation of ex, and what this equals to, this is we do integral from minus infinity to infinity, g of ex and f ex of this is a PDF function of random variable ex, right? And this is a function of ex. This is exactly the same thing. The random variable theta is a random variable now, and this whole thing is a function of theta. And so to find the expectation, we're going to use this formula. The PDF function theta, PDF of theta, that's equals to f theta equals to 1 over 2 pi, I mean theta in between 2 pi 0 to 2 pi and 0 otherwise, right? So this is a PDF function. So now we plug it in here. So this, because theta PDF function of theta only has non-zero value from 0 to 2 pi, so this integral from minus infinity to infinity really becomes 0 to 2 pi. So 3 cosine 2 pi t naught plus theta. And this PDF function from 0 to 2 pi, that's 1 over 2 pi, and with d theta. And doing this integral, we're going to have 1 over 2 pi. We're going to have it out. 3 here. And this cosine integral, that will be 2 pi. 2 pi t naught plus theta. And theta from 0 to 2 pi. So you integral with respect to theta. And this is a constant. This is a constant. Okay, this equals to 3 divided by 2 pi sine 2 pi t naught plus 2 pi, right? So that's 2 pi here, minus sine, and theta equals 0, 2 pi t naught. And this, you take difference of this two terms, that equals 0. Therefore, you can see expectation of this random process given any t naught is not function of t naught, not function of t naught. If we want to take expectation of this random process of any t, that equals 0, change xt naught to xt and take expectation and still get 0. So this is how we obtain the expectation of random process.